At precisely 8:30 a.m. on May 19, 2025, an SBU operator wearing FPV goggles received the long-awaited command, "Send it." Within moments, a Ukrainian-built quadcopter drone carrying 3 kilograms of high explosives launched on a critical mission. Its destination was a Russian-held gas platform deep in the Black Sea, a strategic point that had long hindered Ukraine's efforts to regain control of these vital waters. The operator, known by the call sign Soil, was hidden away in a concealed bunker 35 kilometers from the target on Snake Island. The drone he piloted was no ordinary racing quadcopter, though it was built on a standard 10-inch frame, using Chinese components assembled just days before in a Kiev workshop. This drone had been repurposed into a lethal weapon. Strapped beneath it was a custom-made explosive device, meticulously designed to destroy the radar system perched atop the Russian platform and eliminate any personnel within a 5-meter radius. Hours earlier, the exact coordinates of the target had been uploaded into the drone's ground control system. That target was the NEVA radar installation, mounted on Boyko Tower Alpha, one of several gas platforms seized by Russian forces in the Black Sea. This radar was no simple sensor. The NEVA system provided a detection range of 45 kilometers and had been a persistent obstacle to Ukrainian naval operations for months. Destroying it would grant Ukrainian forces much-needed freedom to maneuver and challenge Russian dominance in the region. This FPV drone represented a revolution in modern warfare, a demonstration of how affordable technology can be turned into precision military hardware. What began as a $500 racing drone had been ingeniously converted into a guided missile through Ukrainian innovation. Its 4 brushless motors revved up to 20,000 RPM as Soil initiated the takeoff from a makeshift launch pad hidden among coastal reeds. Unlike traditional military drones, FPV systems use analog video transmission, which is more resistant to electronic jamming. Through his VR-style goggles, Soil could see exactly what his drone's camera captured in real time, creating a direct, almost intimate connection between pilot and weapon. This link made FPV drones exceptionally accurate, capable of striking pinpoint targets with devastating effect. The flight path was carefully planned to avoid detection by Russian radar systems. Rather than a direct line, the drone zigzagged at an altitude below 50 meters to stay beneath radar coverage. Traveling at 65 kilometers per hour, the 35-kilometer journey would take just over 45 minutes due to this evasive pattern. As the drone lifted off and crossed the Black Sea, Soil watched the water stretching out beneath the camera feed. In the distance, the Boyko Tower rose like a steel fortress, bristling with Russian military equipment and personnel who remained unaware of the invisible threat closing in on them. By 9:15 a.m., Soil's drone crested the final wave, bringing the massive steel platform into clear view. Rising 40 meters above the sea, Boyko Tower's highest point held the NEVA radar system, Soil's designated target. This radar was one of the few Soviet-era systems still functioning reliably. Operating in the K-band frequency at 35 GHz, its rotating antenna array could detect aircraft and surface vessels up to 45 kilometers away. More critically for Russian forces, it could track 200 targets simultaneously, feeding targeting data to weapon systems deployed throughout the Northwest Black Sea. But despite its engineering sophistication, the NEVA radar wasn't designed to withstand a high-speed explosive attack. The 3-kilogram payload carried by Soil's drone may have seemed modest, but it was enough to devastate the radar's delicate transmitters, receivers, and waveguide systems. Through his goggles, Soil could see Russian personnel moving about the lower levels of the platform, unaware of the incoming drone approaching from the northeast. The radar continued its steady rotation, sweeping closer to potentially detecting the threat. However, FPV quadcopters have tiny radar signatures, roughly equivalent to a large seabird, rendering them almost invisible to most detection systems. When the drone reached 800 meters from the target, Soil began the final approach. Unlike artillery or missile strikes that depend solely on preset GPS coordinates, FPV pilots can make live adjustments until the moment of impact. Soil aimed precisely for the junction between the radar antenna and its control unit, the sweet spot that would inflict maximum mechanical and electronic damage. The radar installation grew larger in his field of view. Built by Soviet engineers to endure electronic interference in harsh marine environments, it was never intended to survive a direct explosive hit, traveling at 60 kilometers per hour. Its aluminum housing was designed to repel salt spray and rain, not high-velocity blasts. At 200 meters, Russian personnel spotted the drone and started shouting and pointing. One technician grabbed a rifle, but it was already too late. The drone was moving too fast, and defensive reaction times were insufficient. At 9:20 a.m., the drone struck the NEVA radar's antenna assembly with devastating precision. The explosive charge detonated instantly, sending fragments of aluminum, steel, and electronics flying across the platform. Though small compared to larger military munitions, the blast was perfectly placed. It shredded the radar's waveguide system, destroyed the transmitter, and severed the rotating antenna mechanism. As smoke billowed from the destroyed radar, another far more powerful weapon was already advancing toward Boyko Tower. Although not yet fully confirmed at the time, many suspected that this weapon was on its way. Known as the Seabee, this unmanned surface vessel sliced through the Black Sea swells. A 6-meter-long drone carrying nearly a ton of high explosives, purpose-built by Ukraine's SBU to attack hardened maritime targets. Unlike the improvised FPV drone, the Seabee resembled a high-speed patrol boat more than a weapon, its sleek gray hull concealing 1,000 kilograms of military-grade explosives capable of leveling a city block. The Seabee's warhead was a masterpiece of modern explosive engineering. Instead of a single large charge, it featured multiple shaped charges arrayed around its bow. This arrangement created a sympathetic detonation effect. When the primary charge exploded, it sequentially triggered secondary charges, producing a sustained blast powerful enough to demolish reinforced concrete. The explosive mix of RDX and TNT generated a blast with temperatures soaring above 3,000 degrees Celsius. Against Boyko Tower's support structures, this fireball wouldn't merely damage the platform, it would melt steel beams and reduce concrete to rubble. Powered by twin 200-horsepower inboard motors, driving water jets, the Seabee reached speeds of 49 knots while maintaining a low profile on the water. Its dual-engine design ensured mission completion, even if one motor failed. Navigation relied on a fusion of GPS, inertial guidance, and real-time satellite communications. Though capable of autonomous operation over its 1,000-kilometer range thanks to extra fuel tanks, human operators retained control through encrypted satellite links to make course corrections and select targets precisely up to impact. The drone's stealthy design kept it below radar horizons, and its gray paint blended perfectly into the choppy sea conditions. Multiple redundant communication channels allowed operators to switch frequencies to counteract Russian jamming attempts. Unlike prior strikes against moving naval vessels, Boyko Tower was a stationary, well-surveyed target. Ukrainian intelligence had detailed knowledge of the platform's layout, from storage areas and living quarters to structural support columns, enabling operators to identify the most vulnerable points for maximum destruction. As the Seabee closed in at 45 knots, its warhead embodied the peak of Ukraine's asymmetric warfare capability, 1,000 kilograms of expertly crafted explosives ready to send a fierce message to Russia. At 9:15, with the platform growing larger on their screens, operators watched the lingering smoke from the recently destroyed NEVA radar. But the radar was no longer the mission objective. Their task was to obliterate the platform itself, ensuring it could never again serve as a Russian military outpost. The approach was designed for surprise, exploiting the blind spots left by the radar's destruction. Russian forces were left with only their eyes and handheld radios to detect threats, insufficient against a high-speed drone. The Boyko Tower complex observed through the Seabee's camera consisted of multiple steel-framed levels housing storage rooms, equipment bays, and personnel quarters. Russian forces had transformed this gas extraction platform into a fortified forward base with communications gear, defensive positions, and supplies for prolonged occupation. The drone's autopilot made hundreds of tiny adjustments every second to maintain an optimal course. Its navigation computer processed GPS, inertial data, and visual targeting information simultaneously, flawlessly guiding the drone toward its target. At 9:35, 10 kilometers out, the Seabee activated its terminal guidance systems. The camera locked onto a critical structural junction between the drilling platform and the accommodation block where Russian personnel lived. At 9:35, 10 kilometers out, the Seabee activated its terminal guidance systems. The camera locked onto a critical structural junction between the drilling platform and the accommodation block where Russian personnel lived. Ukrainian intelligence had determined that destroying this point would trigger the platform's collapse into the sea. Accelerating to its maximum speed of 49 knots, the 6-meter drone had become a 6-ton projectile packed with 1,000 kilograms of explosives. The combination of kinetic impact and massive warhead meant total devastation. The platform's defenses were woefully inadequate. Small arms and machine guns designed to repel boarding parties had no chance against a high-speed drone strike. The Seabee's low profile and speed rendered conventional weapons ineffective. At 2 kilometers out, the drone committed to its final approach. The explosive payload was about to reduce Boyko Tower from a military stronghold to twisted wreckage. At 9:50, the Seabee struck the platform's main support junction with the force of a freight train. Its shaped charges focused destructive energy on the structure, causing catastrophic failure. Temperatures in the blast center soared beyond 3,500 degrees Celsius, melting steel beams and vaporizing prefabricated accommodation blocks. Anyone inside stood no chance. Storage areas filled with equipment and supplies fueled raging fires and secondary explosions. Fuel tanks ruptured, sending towering flames hundreds of meters into the sky, a pillar of fire visible from space. Within 5 minutes, the upper structure of Boyko Tower had collapsed into the sea. What was once a multi-level platform supporting Russian operations was now a shattered mass of steel and concrete, jutting from the water like the ribs of a fallen giant. Survivors trapped on unstable debris had no hope of rescue. Fires made helicopter evacuation impossible, and help was hundreds of kilometers away. Ukrainian satellites captured images 2 hours later showing only burning wreckage where Boyko Tower once stood, a stark symbol of Russian occupation obliterated by 2 Ukrainian drones costing less than a few thousand copies of a popular video game. This operation showcased the power of innovation, precision, and asymmetry in modern warfare, where small, affordable, and smartly engineered weapons can change the course of a conflict. It was a vivid demonstration that in this new age, control of the battlefield does not belong solely to the largest armies or the most expensive hardware, but to those who can harness technology with creativity and daring.